All right, so indicator 27.2, graphing exponential functions. Today we're going to be talking about shifts. And you can see here by the color coding, we've got a little bit more to our functions. There can be a shift up in the exponent, which is in red. Those cause a shift to the left or right. You can have a shift on the end, which is there squared in blue, and those are going to shift your graph up and down. Okay, so like I was saying, that blue, I have it in blue. Of course, it's not going to be blue in your homework. But the one that's boxed in blue, that +2 on the end, if it's a +2, then your asymptote is going to raise up 2. And that means your tail is going to run right along but never touch the 2, the +2. If your asymptote is, say, -3, that means your whole graph is going to shift down and your asymptote or your tail is going to run right along that -3. And it's going to turn and it's going to ride right along -3, but it's never going to touch it. So you should find that all of your tail end, whether it's growth or decay, depends on whether it's at the top or the bottom of your T-chart, but your tail end part of your T-chart should always get closer and closer and closer and closer to your asymptote. So yesterday, our asymptotes were all 0. So that means when we started getting closer and closer, we started seeing fractions, right? And I said, make sure you have 2 fractions. Well, you kind of have to grab a hold of the context of that or the meaning of that, but don't latch on to the fraction part of it. Why? Well, because yesterday our asymptotes were 0. So I said, make sure you have 2 fractions so you can really see what your tail's doing, right? And our tail was getting closer and closer to 0, which gave us fractions. Well, when you have a shift, a vertical shift up or down, if my asymptote is 2, no matter how much I work for that tail, am I ever going to get a fraction? Am I ever going to get a 1/2? I won't even get a 1 1/2, right? I can't get anything lower than a 2. So you still need to think about where your asymptote is, where your bottom boundary is, and then make sure you have a couple of points riding toward that bottom boundary. So if your bottom boundary is 2, +2, then you're going to get something like 1 1/2, and then 1 1/4, and then 1 1/8, and then you're still going to get that fraction, but that fraction is going to be riding you closer to the 2 rather than the 0, if that makes sense. So you still kind of have to understand the concept of the fraction, but when you have asymptotes, your fractions or your tail points are going to look a little different, okay? All right, so I think as far as just basic setup, that's really all that you need to know as far as the shifts, what we're looking at. We'll just do a couple of examples here now. So if you flip your paper over, and for those of you at home, I'm sorry you don't have a paper, you just have to draw these out on your paper. We are going to skip number 1 and number 3 because they're simply a review from yesterday, and I don't think that we need to take the time to do that, okay? If you have a question about those and you want to come see me, you don't have to do them. This is not part of your assignment, so just kind of put an X over, skip number 1 and number 3. We're going to move right to number 2 because number 2 is our first example of one with a shift. Okay, so you'll notice that the shift is up in the exponent with the X, okay? And that means that it's going to shift our graph to the left or to the right. And since it's a +2, it's going to shift it to the left, okay? So it always is opposite up in there. So first thing we do, just like yesterday, is we start out with our T-chart. X and Y. And I'm still going to start out with -2, -1, 0, 1, and 2. But I will tell you that when you have a shift, a vertical shift, that's the one that dangles out on the end, you can kind of play with your X's that you start with. And I'll kind of talk to you about that in just a minute, okay? You kind of want your asymptote in the middle, if that makes sense. So if you'll notice yesterday, we didn't really talk about it much yesterday, but the reason you wanted -2 to +2 is because you really want your asymptote kind of in the middle. And that way you get your middle point, and then you get a couple on the tail and you get a couple on the head, if that makes sense. We're going to do that today, but it's just going to look a little different. So this one doesn't have a vertical shift, so we're still going to start out with our basic 5. So same thing as yesterday, it just is an extra step. So you've got y equals, and then our 1/3, and then up in the exponent spot, we've got x, which in the first place, we're going to use -2. So -2 plus 2. Okay, and if you want to save yourself some paper and some space and some rewriting time, if right above that, if you just want to put negative 2 plus 2 is 0, you can do that. Okay, it saves you a little bit of writing, but just know that you're taking your x plus 2 because that's up in the exponent spot with your exponent or with your x. All right, so now we've got anything to the 0 power is 1, so 1/3 to the 0 power is simply 1. So we put a 1 in our t-chart. Now we're going to do the same thing, y equals, and I get lazy and don't put y equals every time, and I'm fine if you do that too. So now we've got in our x spot, we're going to do a negative 1 plus 2. And negative 1 plus 2, oh, that's a 3, isn't it? Not a half. You really got to watch your signs here and adding and subtracting integers because it obviously is going to matter. So negative 1 plus 2 is positive 1. Anything to the first power is itself. So we've got 1/3. And then if we do it again and we do 1/3, and then we have our x, which is 0 plus 2. Well, 0 plus 2 is just 2. And that means we're squaring 1/3. When you square 1, you just get 1. When you square 3, you get 9. So we've got 1/9. Now, this is where if you can stop and think a little bit, you can save yourself some trouble and some time. What's my asymptote here? I don't have a vertical shift up down. Yeah, my asymptote is always decided out here, and it's 0 still on this particular problem. So I know that my problem or that my graph is going to ride along the 0. I already have negative or a 1/3 and a 1/9. I can keep going with 1 and 2, but all it's going to do is give me bigger and bigger, well, actually smaller and smaller fractions, right? So when you get to this point and you see that you're hitting 1/3 and 1/9, and if you can even mentally in your head go, if I do 1 plus 2, that's 3, and 1/3 cubed is 1/27, I'm just getting tinier and tinier fractions. Stop. Stop here, add some, give yourself your head points, okay? So because you need 5 points to graph, and I'm stopping here at 3, I'm going to go ahead and add negative 3, and I'm going to have to put it above it, but negative 4. Okay, so I'm going to stop here because these two don't even make sense to keep going. I mean, they do. They're points on the graph, but you don't need that tiny of a fraction. So now I'm going to switch gears a little bit, and I'm going to go back up to negative 4. So I've got 1/3, and then I've got negative 4 plus 2, which is going to give me 1/3 raised to the negative 2. And now I deal with that negative by flipping my fraction to a whole number, which is good. That if you start getting whole numbers, that tells you you're starting to build that head up a little bit. So when I flip this over, I get 3 squared, which is 9. So when I use negative 4, I get 9. And then I'm going to use the negative 3. So 1/3. If you can do this in your head, I'm fine with it. Just watch your signs. Negative 3 plus 2 is negative 1. I flip that over and I get a whole 3 to the 1, which is just 3. Now I've got 5 good points. I've got 2 good fractions that are on the other side of my asymptote, or that start riding toward my asymptote, so that kind of helps a little bit. All right, so at 0, you get 1/9. I'll graph these in red. Maybe they'll show up a little bit better. At 0, you get 1/9, so just barely on top of the line, right? Right at the 0. At negative 1, we get 1/3. Again, just kind of as best you can, barely over the line. At negative 2, 1. And then at negative 3, we got 3. And negative 4 gave us 9. Oops, what's off there? Negative 2, 1. Oh, 2. Thank you. I could tell it was off. I could tell it wasn't in line with the rest of them, but there we go. Thank you. Negative 2, 1 helps if you graph the right point. There we go. I could tell it was outside of where it should be, but okay. Now they're all kind of in that swoop line. Now you've got a good, like I said, you've got 2 fractions. You can tell your tail is going to ride right along the 0, and that falls in line with our asymptote being of 0. And then our head shoots up here. And if you'll notice the difference, kind of where your points were from yesterday, your fractions were more at the 1, 2 spot. And when you got to that 0 mark, you were up a little bit. It was 0, 1, 0, 2, somewhere along in there. So basically your whole graph just, if you're looking at it here, your whole graph, what it would have been centered here, and your whole graph shifted this way plus 2 or backwards 2. So instead of having your curve points here and your fractions here, everything shifted over 2 spots. Okay? All right, so now let's look at the last example here that we're going to do, and that's number 4. And this one has a vertical and a horizontal shift, so we'll look at both of them. We can tell by our x minus 2, we can tell that this is going to shift over on the positive side of the graph a little bit. And we have a different asymptote here, okay? And you can see that, right, the worksheet, the creators of these worksheets kind of adjust your graph accordingly, because if you look at number 3, we're not going to do it, but look at number 3, they don't even give you a graph lower than 0 because 0 is your asymptote. Here, your asymptote is -2. And that means that your graph is never, ever, ever going to drop below this invisible boundary right here. Okay? That's your asymptote. And that is your invisible boundary. And your whole graph now is going to shift down to, and now your tail. So when we're going for points here, or when we're going for tail points here, we need to make sure that we're getting a couple of points that are heading really, really close to -2 now. So we might have to shift our points here. So first, let's do our t-table. And I'm going to give myself a lot of room here just in case. So -2, -1, 0, 1, and 2. I'm going to start there. Okay. Now, these take a little bit more time, and PEMDAS is so important. Okay. You have to do exponents first. You have to get that exponent whittled down to a single number. Then you have to deal with applying the exponent. So there's kind of 2 steps in the exponent here. Then you do, if there is any, you do multiplication. I'm trying to see on your homework if there's any shifts and multiplication. Nope. Then you would do multiplication if there was any. Then the very last thing you do is addition and subtraction. So the very last thing you do is that -2 that's dangling on the end. You add that to your number. All right. So these take a little bit more, but that's okay. We can still run through them. It's still basic math. It's just got to do it in the right order. So we have 4. We have 4, and then up in the exponent spot, we have x minus 2. So -2, -2. And then -2 is our shift, or our vertical shift. So first thing I want to do is get that exponent written down as one number. So that would be 4 to the -4. Nope. Yeah, -4. -2. And then we got to deal with that negative exponent and apply it. So we have to flip the whole 4 over to 1/4 to the 4 -2. And then 4 to the 4th power is what? It's really, really big. It's 256, I think, right? Yeah, 256. So now we have 1 over 2, 5, 6 minus 2. Now, I know this looks really overwhelming to do. If you have a calculator, put it in your calculator. If you don't, just -2 is the bigger number, right? Or the 2 is the bigger number. You know you're going to end up with a negative. And 1 of 256, that's a huge fraction, or a very minute fraction. I always say it wrong. But if in your calculators, if you'll put 1 over 256 minus 2 and hit equals, you're going to get 1.99, negative 1.99. So if I were you, that's what I would do. Put it in your calculator. If you don't know how to do a fraction in your calculator, it's really easy to do it in your calculator even without using a fraction button. If you'll hit 1 divided by 256, that converts that. So if you hit 1 divided by 256, that converts that fraction to a decimal. Then just hit -2, and again, I got negative 1.99. Super simple to put in your calculator, all right? Don't try to make this harder than it is. Use your calculators because you'll always be able to use them in my class. All right, so we get negative 1.99, which basically is what? Almost negative 2, and we knew that was going to be the case because our asymptote is negative 2. All right, so I'm just going to have to, because I don't have the space here, I'm going to have to keep deleting here and adding to this. So now we're going to do negative 1 minus 2. And then we're going to have to work it all again, okay? So negative 1 minus 2 is negative 3. Okay, negative 3 here is, flipping it over, is 4 to the third, which is 4 times 4 is 16, is 50, 60 what? 64, thank you, minus 2. Now, notice I'm going to get a real tiny fraction here. I'm going to get 1 point something, and it's going to be really close to 2 again. So if you do 1 divided by 64 equals minus 2 equals negative 1.98. All right, now, do you even need, like, negative 1.99 and negative 1.98? You've got your two fractions that you need, okay? So if you want to either skip negative 1 or even jump to 0, because if you'll notice, what I want to say here? What's the next x, if I skip a couple, that I'm still going to keep it flipping as a fraction, if that makes sense? When I think about x minus 2, if I do 0 minus 2, do I still have a negative that I'm going to flip? If I do 1 minus 2, am I still going to have a negative? Okay, what if I do 2 minus 2? Is that where I lose my negative and I don't flip anymore, right? So only do 2 of the ones that are going to cause a flip and a fraction, if that makes sense. So I don't need to do negative 2, negative 1, 0, and 1. All 3 of them are going to give me tiny fractions really close to negative 2. So just pick 2 of them because you want 2 in the tail. All right, hopefully that makes sense. So if I do 1, right, if I use 1 and I do 4 and then 1 minus 2 is negative 1 minus 2, I flip that over and I get 1/4 minus 2. And in my calculator, I do 1 divided by 4 equals minus 2 equals negative 1.75. You can fill in the other 2 if you want, but you're just going to get tiny little decimals in between those 2 that aren't going to really help you. Now look for the first one that's going to give you that 0 up in the x. So which one of these, let me erase all this real quick. Which number, when I put it in my exponent, is going to give me that 0 as an exponent? What do you guys think? Chloe, what do you think? A 2. So that's why I skipped down where I skipped, okay? You don't have to skip them all. You can fill them in if you want a whole bunch of fractions or decimals. It's totally up to you. I'm going to skip to the 2 because when I do 4 raised to the 2 minus 2 and then minus 2, I get that 0 exponent. And anything to the 0 is what? Hayden? 1 minus 2 is? Luke, what is it? Negative 1. So when you put 2 in, you get negative 1. I've got 2 decimals or fractions. It doesn't matter if you write them as decimals or fractions. It doesn't matter to me. But you've got 2 tail end going toward your asymptote fractions or decimals. Then you finally get a whole number. You want that whole number kind of in the middle. You want that start of the whole number kind of in the middle. That tells me, right, that I need to add a couple for the head. So again, you can do this part in your head if you want. X minus 2, 3 minus 2 is 1, right? I'm doing that just kind of one step in my head. I'm plugging a 3 in here. 3 minus 2 is 1, and then minus 2. 4 to the first power is 4, minus 2 is 2. Okay, my numbers are getting bigger, which is what I want. And then the last one, I'm going to do a 4. Well, when I do 4 raised to the 4 minus 2 is 2, minus 2. 4 times 4, or 4 squared, is 16, minus 2 equals 14. Now I've got a good head, okay? You can do the other 2 in the middle if you want, but it's not going to help you in graphing, and you're still going to have to add the 2 to give you that head spot. All right, so let's graph these. -2 and then negative, just about as close to -2 as you can get because that's your asymptote. So -2, -2. I'll do these in red and see if I can't make them a little bit bigger here. -2, -2. And then I skipped -1 and I skipped 0 because those weren't going to help me any. And I went over to 1. And you can see that 1 is still, right, still just almost barely at that -2. I mean, it's right on there. And then it finally, at 2, -1, I finally rise up a little bit. And then at 3, 2, I rise up more. And then here's your big jump, 4 all the way up to 14. And that's your big jump that defines where your head ends up. So you've still got your giant shoot up through the head, and you've still got your tail riding right along your new asymptote of -2. So the thought process here, you're just gonna have to slow down a little bit and look at your problem, figure out where your asymptote is gonna be, and then figure out what I like to do is I like to look up into this spot right here. I like to look right here and ask myself, what number is going to give me 0 here? Make that kind of your middle point. Because if you make that your middle point, you're going to get a couple on the tail and you're going to get a couple on the head. Okay? So in the ones with shifts, I'm even okay if you don't start out and put -2, -1, 0, 1, and 2 in your T-chart. If you can think ahead enough and you can look up at your graph and you can look at this part right here, and you can ask yourself, what's going to give me a 0 here? And in this case, it was +2. Make that your center and then go a couple above and a couple below. Does that make sense? And then your shift, this one right here, this one it's not going to affect picking your X's. It's just going to shift your whole graph down, okay? Or up if this is a plus. Make sense? Good? Some head nods, even if you're faking it? There we go. Thank you. All right, so I've got your homework assignment for those of you at home. Go ahead and click on Load on Cami and make sure you show all of your work with the T-charts and all the work to get your numbers in your T-charts if you want credit.